Now unfortunately I got so carried away with all of the planing and jointing that I overheated the bearings in the worm drive and chewed out the plastic teeth on the worm wheel. So I've now ordered all the components to get in here and just replace this sort of half-assed drive system with an independent stepper motor. This is my lovely thicknesser planer from the Swiss company Inca. I've already done a review on it, I'll leave a link, but unfortunately last time I used it I wrecked this drive mechanism. Now jointer planers have two functions. The top part is the jointer, and that's used for flattening boards and making two sides perpendicular to each other. The second function is the thicknesser function to bring the other two sides down to parallel with the first two. This main motor has got this flat belt pulley, which is about a 1 to 2 speed increase to drive the actual planer blades. And this motor turns at nearly 3000 RPM, and therefore the planer is turning at about 6000. So how do you drive feed rollers which only need maybe 20 RPM off a 3000 RPM motor? Well, that's this mechanism. So here on our main motor there's a second pulley driving this round belt, and now this round belt turns this pulley, which is turning this worm gear. Because the main motor is turning so fast, the pulley's turning really fast, and the whole thing has a lot of friction and heats up pretty fast. This shaft's got needle bearings in it to keep it very low friction, but of course there's so much dust floating around that you're constantly having to wash them out, constantly having to lubricate them. But if you don't, they heat up and they can chew out the plastic pinions or nylon pinions, which drive through the chain, which drives these feed rollers. And that's of course exactly what happened when I was making my workbench. Now it seems everybody who's ever owned one of these Incas has found this drive system unreliable. Inca themselves recognize this. There's a later model which replaces this whole drive system with some sort of planetary gearbox. I'm not sure if that works any better or worse, but I don't have it. Now it's clear back in the day, in the 1980s, it was very expensive to put a second motor on something, and therefore they tried to use a single motor with a mechanical speed reduction. Would have been better if they'd used a real gearbox, but hey. Nowadays, motors and electronics are cheap enough that the better solution is probably just to disconnect these rollers and their drive mechanism from the main spindle motor. So that's what we're going to do. So the plan's pretty simple. Keep the sprockets, the chain drive, remove the belt, this tensioner, this whole mechanism, and especially these pinion wheels, and just replace it with a stepper motor to drive the chain. Plenty of other people have done this. I've seen someone do it with a NEMA 23 stepper like this, so I hope it works. Mail time. So what do we got here? A stepper driver. So this is, I think, the little buck converter to drop 48 volts to 12 volts. Came as a pack of 2. The 48 volt power supply to power it. Cool, the little chain drive cog. Okay, so this should run on this hollow shaft, and it seems really quite stiff. The lubricant inside hardened. I didn't pick it up on it in time. That's probably root cause of why it failed. Lack of maintenance. Okay, so this chain tensioner is pretty primitive, so I'm not sure if I'll reuse that or not. It's just a piece of spring wire with a plastic roller on it. The motor's only held on by 3 bolts, so it's probably easiest just to drop it to make it for easy access. The good news is the bearings feel quite nice. Right, so I've got 3 existing holes to work with. And my new center line of my stepper motor is going to be determined by this arc, roughly. We can probably increase the precision of that drawing a little. So center to center, 140. This one looks like it's center to center, 64 and 112. I got a motor. That's going to do the work. But stepper motors are stupid and don't have commutators, so you need electronic commutation, otherwise known as a stepper driver. Stepper driver is going to need something to give it pulse and direction signals, telling it how fast to turn. So I got one of these little widgets, turn the pot, and it outputs a pulse stream. Start, stop, change direction. Now we're also going to need muscle power to drive the stepper motor. 48 volt power supply, real simple. And this little board also needs its own power supply. So that little baby there is whatever, 24 volts or 12 volts. I think you can adjust it. Then I'll need a few other bits and pieces like a knob, probably a switch. I might try and bring the on-off switch off this board onto an industrial switch on the outside. Maybe a change direction switch. I'll probably need a few little connector blocks just to wire everything up. A few gland nuts, and there's my little drive pinion. So how hard can it be? Now I just need to glue it all together. Now when I got this machine, I noticed that the last owner had put some electrical tape on the main power cable. That's never a good sign. Looks like its insulation's cracking up a bit. But look, there's a little love letter in here. Yep. Wiring diagram. That's the electrician's version of a love letter. It says here that the motor has an electronic brake on it. 10 seconds after you shut it down, it'll brake to a stop. That brake stays engaged for about 12 seconds. Kind of interesting packaging. The circuit board's under enough tension that it's bent. Looks like some of the components are sitting against the relay, but hey, it's worked so far. Right, well, after a bit of faffing around, I cut off that perished piece of cable and got it all wired back up. So I'll put the love letter back in and it can all go back together. Now my first instinct would be to try and pack all of this into the smallest possible box that I could possibly get it into. But then I realized, wait a minute, I've got this little electric cabinet which has been following me around for at least, I don't know, 20 years probably. I bought it from a friendly scrap metal dealer. Right, now I've laid out the back plate of my cabinet, so let's mount some parts. Okay, so that's my basic layout finished. Next up, I need to do all the wiring. This control cabinet's got a nice opening at the top, and I had this plate to cover up the opening, but the holes are too many and in the wrong place. I'm always in two minds with this sort of thing. Do I go through the effort of drawing it up, doing it on the CNC, where it's kind of a pain to actually fixture thin sheet metal? And for a one-off, I'll probably just do it by hand. So I've just whipped up another plate, and I'll cut the correct holes into it. It's going to need holes for e-stop, on left, on right, and speed control. And then it's going to need 3 gland nuts for power in, power to the main planer motor, and power to the stepper motor. Right, next up I need to work out how to mount the whole thing. First thing first, I've just bolted a bit of angle iron on there. It's all weird angles, so I'll try and make it parallel to that. That'll do for the start. I think I'll just pick up this existing bolt hole here and use that as the top mount. My first idea was to make up some sort of a bracket between this bar and here, but I've realised if I just use a bit of all thread through the hole, I can just weld that straight to the bracket. That'll do it. Right, now let's get this tacked together. my dog looked like this, I'd have to shave its ass and teach it to walk backwards. You know, when I do the practice with the practice pieces, I can start getting something somewhat predictable. I mean, I've still got a lot of work to go. Yeah, as soon as I get away from my standards, it all seems to turn to custard a bit. There are two good things about this weld. One, I think I've melted enough blobs of steel onto there that it probably won't fall apart. And the second really awesome thing about this weld is that it's going to be upside down and hidden. Well, I would like to report that all of the lessons I learned from the first one applied to the second one and I got a perfect weld. Well, nah. I've got most of the wiring done now and I decided to do a quick test on the motor. The motor is correctly connected to the drive. It's getting its muscle power because it's holding the torque. That's good. But when I turn motor rotation on, nothing happens. The little step motor controller board, it's kind of a dumb design because it's got a potentiometer that comes off the board at right angles, but two switches that come vertically off the board. So what I did was just desolder the two little switches and solder from the circuit board into this sort of switch block here. In each direction there's an on switch, and on the in direction there's also the reverse direction switch. I fired it up, I found the motor's getting power, it locks in rotation, but I can't control it. So I think I need to jumper the second switch here. Let's try that. Alright, let's plug this in and see if adding that jumper actually did anything. Nope. Okay, now I've worked out what I did wrong. When I first measured these switches that I removed, I assumed, like most switches always have the common pin in the middle and then like switch 1 and switch 2. Yeah, don't assume things, because it turns out on this switch the common are actually the corner pins. From a schematic, it's a normal double pole, double throw. Guess that should have been obvious. So how's that look? Only momentary. Only momentary. Momentary. Simple. I don't know if I've got any latching switches. Maybe I can ask my mate Phil. Alrighty, thanks Phil. Alright, well now of course, got the wrong holes. I could make up some sort of little blanking plate with 2 holes in it, but I guess I'll just make another panel. Shame I didn't draw it up and do it in CNC the first time, because then it would be really easy to redo it the second time. Okay, so I got it all installed and wired up, but it's still not working. The motor still won't turn. So my stepper drive is getting nearly 48 volts, and the speed control board's at 12 volts. The board turns on, switching the board on, turns on the enable signal to my controller. Wait a minute, why is that polarity reversed? Maybe that's the key. Okay, so I found the problem. There's no instructions for these Chinese controllers, so you just sort of go searching through the internet for photos and stuff, and I obviously found one where the polarity was reversed. On the board I bought, it shows the anode on connector 5, but on another schematic I saw it's on number 4. But now, hooray, it works! It's a 6mm bore in the chain sprocket, and of course it's a 1/4 inch shaft on the stepper. So I've got a 1/4 inch reamer, but 0.35 of a millimetre is too much to take off with a reamer. I think I'll grind up a lathe tool out of this old broken tap just to take off most of the meat. Okay, so I've ended up with a very, very weak, sharp edge. So I'll have to see if it works using very fine cuts, or if I have to grind some more. Okay, so just tweak the grind on this. I'm going to need some sort of a motor mount, so quickly whip something up in CAD. Now I made it in 2 parts to allow for some chain tensioning, and although everyone would like me to mill these parts, I'm now so late. If I throw them on the 3D printer, it means I can edit this video while they're printing. Also, if I screw anything up, I can have a prototype plastic part, and I can still make a metal part later. I think I'll do that. Well, it's now Sunday morning. These are the prototype parts I got printed. They're not perfect. I had to do a slight modification because I didn't make those through slots. Fixed that with the soldering iron. Kind of racing against time. Let's try and get these all wired up and see what I need to modify. I wonder where I've put my Allen socket set. Haven't seen that for a couple of weeks. Okay, well I definitely need to redesign the adapter plate and put a countersink into it and get a countersink screw to mount that end. At the moment that's just flopping around. The next thing I'll need to do is probably extend this motor mount further up so that this screw here sits somewhere up in here, because at the moment I've got interference down here between the chain and that screw. Right, but before I mod anything, let's mount the cabinet. Okay, so how does that look? And more to the point, well, is it going to work? So the brake's going on. I thought it broke faster before, but maybe I'm wrong. There's our drive. Definitely going to need it definitely needs a little bit of a redesign for those brackets. Other direction. Oh, that's actually the direction it's supposed to travel. If this is too slow, I can still jumper the driver for a different speed. One thing I still need to do is cut down this cover and make it fit. Need a cutout for that motor. Well, that sounds to me like this stepper's not powerful enough. This is only a 2 amp stepper. Nowadays you can get modern NEMA 23s which are quite a bit more powerful than this, so I think I'll probably have to replace it with a more powerful motor. I need to redo the mount anyway because that's crap, but I'm out of time, so I think I'm going to leave it like this for the moment and order those parts. I think I'm going to close out on this for today. Still needs more work, but I'm out of time. Thanks very much for watching.